you take a typical internal combustion engine and look at its torque speed and power speed characteristics. So, the plots are going to look something like this. So, the torque output is first going to increase its speed and then it will reach a peak at a speed which we are labeling as some omega t, and beyond that the engine torque starts to fall. Okay. So, so you can immediately see that the engine torque output increases its speed, okay, reaches a maximum and then starts falling. Okay. Now, another point which we have to observe is that, like in an internal combustion engine, the engine itself provides very little torque when the speeds are low and practically no torque when the speed is close to 0. Okay. So, that is why when we operate with an internal combustion engine, we require what is called as a move off element. Okay. So, to remove the vehicle from rest. Okay. So, that is something which we are going to discuss shortly. Now, if we look at the power speed curve, so the power keeps on increasing with torque because power equals torque times omega, right, and when the torque is the highest, the power reaches some value. After that, even though the torque falls down, the power keeps on increasing but at a lower slope, right, because the torque is falling down. Speed is increasing, but since the torque is falling down, the power increases, but the rate at which power increases with speed essentially starts dropping down, and then power reaches a maximum point, okay, beyond which the torque starts to decrease so rapidly that the power also starts to drop. Okay. So, the speed at which we get the maximum power, we call it as omega p. So, this is the maximum torque, what is called as the rated torque, and this is the rated power. Okay. So, now we can immediately observe that the shape of the torque speed curve of the internal combustion engine is nowhere close to what we require. So, what did we require? We wanted a shape in the form of a hyperbola. So, this hyperbola is what is called as an ideal traction hyperbola. Okay. So, this sort of characteristics where the power is constant and the torque behaves like a hyperbola, that characteristics is what is called as an ideal traction hyperbola. That is what we want ideally, alright. But then we see that the IC engine torque speed characteristics is something like this. So, it is not even in the shape of an hyperbola, right. So, it is highly different from what we want, okay, and that is one primary reason why we go for a multi-speed gearbox when we want to operate a vehicle with an IC engine. Okay. So, let me first write down what are all the limitations of an IC engine, which then motivate the transmission as we use it today, right. So, the IC engine, it cannot provide sufficient torque at near zero speeds. So, this implies that we require what is called as a move off element, like a clutch. To move the vehicle from rest, okay, because to overcome the limitation of the IC engine, okay, at very low speeds. Then we can observe that the engine can provide maximum power only at a certain speed. Hence, the IC engine per se cannot meet the ideal traction hyperbola, okay. So, this we will observe shortly that it requires a multi-speed gearbox. And another limitation of the IC engine, which it becomes important when we want to look at it from the perspective of fuel economy, is that like although not directly visible from this plot, so fuel consumption in an IC engine is strongly dependent on the operating state or point. Okay. So, that is another what to say aspect of IC engine that we need to keep in mind. So, if we are not able to meet the ideal traction requirements with this characteristics, how do we do that? Okay, so let us quickly take a look at how it is done, at least the philosophy. Then as I mentioned, like when we go for the analysis, we will do the actual calculations. So, why do we require these multi-speed gearboxes? Something which we will discuss now. Okay. So, before we come here, why do we think IC engines are still popular, like why are they used? So, I talked about limitations of IC engines, right. So, we can see that we want a traction curve which is in the form of a hyperbola, right. We are not even getting a shape that is close to being a hyperbola. So, consequently, we require so many other elements, multiple gears and very low torques at low speed. So, we need a clutch, right, a move off element to move the vehicle and so on. So, despite these limitations of IC engines from a perspective of a powertrain, from a perspective of an ideal prime mover, why do you think the internal combustion engine is still popular? So, from the perspective of powertrain, few advantages of IC engines, because we should have a balanced viewpoint, right. So obviously there must be a lot of good things about IC engines, like that enable it to have been used for a long time and still being used, right, from the perspective of powertrain. So what are these advantages? So the first advantage is that the internal combustion engine has a high power to weight ratio. So that is a very important advantage. So in other words, if you want a particular power output from an internal combustion engine, like the mass of the entire prime mover will be pretty low comparatively, okay, compared to other choices which are available. Okay, so that is a very good advantage of an internal combustion engine. Another advantage which is also like beneficial or adds benefit to the use of IC engines in this application is that the fuel which is used has high energy density. So that means that if you look at the amount of energy which we get by burning unit quantity of the fuel in an IC engine, that is going to be pretty high. Okay. So this implies that we are going to essentially have this advantage of relatively compact energy storage, and that is a big advantage or a plus point for an IC engine even today, right. If you take even like alternatives like batteries, fuel cells and so on, right. So the energy storage system, from the perspective of energy storage systems, like IC engines still have a tremendous advantage, right. And added to this, like some practical advantages of faster refueling and essentially like availability of the infrastructure already in place, right, for refueling and so on, like have sustained the application of IC engines in this domain. Okay. So but we are going to be interested in from the perspective of the engineering side, right. So why do we use a multi-speed gearbox, like in internal combustion engine? So let us look at that perspective. So as we just discussed, so if I plot tractive effort versus vehicle speed, this is the ideal traction hyperbola. So as indicated here, let us say this is the characteristics of the IC engine. Okay. So if it is used as it stands, we can see that there is a huge mismatch between the ideal traction hyperbola and the IC engine characteristic, right. So the shaded region indicates the mismatch in the traction that is required and the traction that is available from the engine. So what do? We use a multi-speed gearbox. So typically when we use a gearbox, and we provide a input torque and we get an output torque. By and large, in most automotive gearboxes, in the lower gears, the so-called gear ratio is greater than 1. So that means that the output torque is going to be more than the input torque. So what happens is that, like if you look at this first gear, the question becomes, how did this curve become like this? So what happens is that when you multiply it by, let us say, a factor of, let us say 4, just taking some number, right. So what happens to this curve is that the torque output gets amplified by that factor, right, it gets multiplied by the factor. So as far as the curve is concerned, it gets shifted along the vertical axis, right. But what happens to the horizontal range? That gets shrunk and shifted to the left. Why? Because the output torque is going to be the gear ratio multiplied by the input torque, okay, but the output speed is going to be input speed divided by gear ratio. So if I am magnifying the input torque by a factor of 4, I am also scaling down the input speed by a factor of 1/4, is it not? So the speed range is going to be shrunk and it is also going to be shifted to the left, and that is how we get this curve, right. So you see that the engine output curve is modified into the curve which is shown as under first gear there. Similarly under second gear, third gear and so on, okay. Now when we are driving a car, right, let us say we engage in first gear and then we start moving. So we can immediately observe that we are going to go close to the ideal traction hyperbola, still there is a mismatch, right. So we go close to the ideal traction hyperbola, and let us say as we go to higher speeds, what is going to happen is that this scaled curve is going to move away from the ideal traction hyperbola. Then we will feel the engine dragging, right, because the engine output is not able to meet the requirements, right, which are essentially coming on the powertrain. Now we switch to the second gear. So what happens? The operation of the transmission goes like this. So then we go along the second gear, and then after some time, even when the gear is in second gear, the torque speed characteristics of the other transmission output starts moving away from the ideal curve. So then what we do, we shift to the third gear and the curve goes like this and so on. So you see that, you know, like we essentially try to follow on the profiles of the various scaled curves corresponding to the different gear ratios while remaining as close to the ideal traction hyperbola as possible. Still there is going to be some mismatch, the fit is not exact, some mismatch, but we can see that with the multi-speed gearbox we have largely reduced the mismatches. So that is a advantage. Of course, higher the number of gears, better will be the match, right, because we can have a finer resolution as far as the speed range is concerned, in which we can switch gears, okay. So but then the cost of the gearbox would obviously increase, right. So there is a trade off between the number of gears and the complexity and cost of the system. However, we still have to solve one more problem, right. So this is the philosophy behind how a multi-speed gearbox essentially addresses this mismatch between the engine characteristics and the ideal traction hyperbola, right. Of course, who changes the gears? If you have a manual transmission, the driver changes the gears. So we should know when to upshift and downshift, and we get a sensory feel, right, on when this point of transition is, right. These are all points of transition from one gear to another, right. So we get a tactile feel of when to change, right. Still we have to address one issue. What is that? Which is this, right? No matter, like whether we use a gear, a high first gear or not, a high value of gear ratio of the first gear or not, still if you want to move off from rest, we need a clutch, we need a move off element, okay. So that becomes extremely important when we want to essentially move the vehicle from rest. And not only that, a clutch also becomes important when we want to change from one gear to another, okay. So we will learn about all those functions of a clutch and how a clutch is actually realized in practice in the next class, okay. So I will stop here for today. What we have done today is essentially to have a broad discussion of what a powertrain is, what the requirements are, and what we actually have with an IC engine and why we need multi-speed gears. We will continue with clutches in the next class. Thank you.